Hey class, today I'm just going to give you a brief introduction to writing in the natural sciences and some things you might encounter as we move through this unit. So what are the natural sciences? What is that writing basically going to focus on? Well, the natural sciences focus on the physical world, including the human body, and that study of that physical world. This can include stuff like biology and chemistry and mathematics, but it also includes what we call our applied sciences, so something like engineering, computer science, allied health services. All those fall into the study of the natural world. It is a very problem-solving based discipline. So in health sciences, we want to help solve medical problems. Engineering, maybe we need to solve a problem of how a bridge is or is not working. In biology, we need to solve the issue of like maybe ecosystems or how different life organisms are working together. So it's a problem-solved based discipline, and the writings will reflect this a lot. There's going to be a lot of analysis, observations, interpretation, and technical discipline-specific language. In the natural sciences, you have both topics and a focus. So a topic is like the subject matter, and the focus is the approach to that subject matter. So an example, if maybe my topic is the Atlantic Ocean, I can have different focuses based off what career or research path I'm in. So a marine biologist might study the ecosystems in the Atlantic Ocean. A chemist might study plastic compounds or the chemical makeup going on in different areas of the water. The tectonics or flora or coral formations, maybe a geologist is going to study. The ocean temperature matters for a meteorologist because some storms are based off those temperatures and it can give us an idea of what's going on. So when we think about the natural sciences, we have to consider the fact that a single discipline or subject or topic can be approached in multiple ways. So the writing and research in this area will be based on overall research questions that we can narrow down. These research questions can be a theory, a problem they want to solve, a simple interest, like that you personally are interested in, and then you just narrow it down by looking at causes or consequences, processes happening, categories, values, correlations to other events. You just narrow it down to a very specific region, because if it's too broad, you can't design an experiment or a field observation that would allow you to address this question. Researchers will end up making a claim, or more commonly known as a hypothesis, that they're going to either design an experiment or observation around to prove or disprove. So if you remember in possibly past science classes you've taken, you might follow this scientific method where there's a hypothesis and you have to design or follow an experiment, record the data, analyze it, and then say what that means in terms of that hypothesis, if it's true or not. This should hint to you that the natural sciences writings and research are argumentative by nature. We're not just reporting facts or results as much as it feels that way. It may feel dry, but we're arguing what it means. And scientific consensus is not proven by one experiment. So that means there's an ongoing argument and dialogue happening, trying to say like, well, maybe these methods aren't the best way, and this would prove this. Or maybe you didn't have a big enough experiment sample size. Or maybe like, I agree, but have you considered this? So it is very rare to see someone in this realm say, this experiment proved this hypothesis. You could say it suggests it's correct, or it supports that this is the correct viewing, but very rarely have we proven something with just one experiment happening. So what type of support do we need to think about here? Well, there is going to be a section where you're reviewing the research or other experiments writings already done to kind of give a basis for why you're doing what you're doing. But a lot of our support is going to be quantitative, because it's going to become numerical based off of our experiments or observations. It's going to be objective, meaning you need to keep yourself and personal feelings out of it, whether or not you like the results. It's going to be empirical, so it can be measured or tested, but you don't just throw the numbers in there. And we're going to come back to that. There's numbers based, but that's not the end of it. It is also not uncommon to see some qualitative data. This happens a lot if there's a lot of field observations and it's something that you can't explain through numbers or measurements, but you have to then describe very accurately and with detail. If there's images, you can include those in the report because that makes it easier. Like, they don't have to take your word for what you're describing. They can actually see it themselves. And to use this support, there's a couple different ways you can do a they say, I say approach that you might be familiar with from English 111. So if you are using research from other people, you might say like, other scientists believe this, but I go this way, or, you know, former research has supported this theory, however, new empirical evidence suggests blah, 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 blah. You need to explain and analyze your interpret, explain, analyze your data, like I suggested in the last slide. So, what does the fact that you had 6 chicks hatch after listening to rock music, what does that mean? What does that tell us? Don't just, oh, this happened, well, now what? You also need to be strong and convincing because your fellow scientists are going to be not rudely, but poking holes and looking for areas where you may not have fully considered things. So be strong and convincing, use strong verbs, be thorough, and consider what objections might be brought up to your research. So that way you can say, well, like, yeah, in your essay, you can go ahead and address, like, yes, this may have been in cold weather. However, this is inadequate research because this problem deals with cold weather animals. Be thorough. You don't need to be overly wordy, but make it clear that you have thought through everything so there are less holes for people to poke. Convention-wise, most natural sciences writings are going to be in third person because we want to maintain that objectivity. Can be kind of neutral, meaning you shouldn't be overly passionate because this is an objective field. So you should kind of be like neutral and let people find the evidence and reasonings through the data, not through your like personal feelings. You're going to be formal and use precise language, be clear and to the point. There are headings and subheadings throughout the writing to make it easier to navigate the research and argument. They use tables, figures, and charts, which are numbered and introduced. So you don't just drop a chart and then never speak of it. You have to introduce it and talk about it in the writing. But it also should be numbered. So you can say, like, when you look at chart number 1 or graph 1 or table 3, whatever, they can know exactly where to go to. Natural sciences often use the Council of Science Editors formatting rules. This class we're going to use APA, but that is the common one, and there's a couple others they might use, but normally you'd follow those conventions as well. However, like I said, we're going to use APA in English 112. So organization-wise, you will get more information about this later, but experiments and lab reports mainly follow the IMRAD format. General format is introduction, the methods, research, analysis, and discussion. So those are your headings, and then under those would be that content. It's not uncommon to see an abstract beginning. In fact, that's like more common than not. It just doesn't sound as good, the IMRAD. But you also can have like an additional conclusion section if the author, the researcher feels that more steps need to be taken. Where do we need to take this further? There are a lot of perks to using the IMRAD format. First, it's streamlined. Everything is going to be the same. It's just easy to go. You plug and chug. Readers can navigate the content with ease. Say I just want to look at their methods. I know where to find that. I don't have to read the whole thing or jump around. Or if I'm not interested in their methods, I just want to see the discussion to know if this is research that I can apply to my own research. I can jump straight to that section. This allows for the replication of experiment and hopefully confirmation of what you feel happened or really would happen for somebody else. It also provides accountability because people know what to expect and they know what you should include. So we're all fitting that same format and making sure we're doing the same thing for accountability's sake. But that is the natural sciences, and I look forward to seeing what you discover.